Hello viewers, welcome to CEC lectures. Myself Dr. Preeti Jagwani. I am from Department of Computer Science, Aryabhat College, University of Delhi. So in this ongoing lecture series of ours, which is named as Introduction to Programming Using C++, presently we are studying inheritance, and in the previous lectures we have seen what actually inheritance is, and among the 5 types of inheritance we have seen single inheritance and multiple inheritance in quite detail in the previous lectures. So our today's agenda is, in among the types of inheritance we will go through multi-level inheritance and hierarchical inheritance. So in order to begin, let's go with multi-level inheritance. So multi-level, whenever I am talking about multi-level, that means there is a situation in which a class can be derived from another derived class. So for example, let us say there are 3 classes A, B and C. A is the base class that derives from class B, and now B is the, or we can say B is the derived class of A and A is the parent class of B. Now considering B as the parent class of another class C, here we will be able to create a structure of inheritance which is having multiple multi levels. One is A, which is the base class for B, and another one is B, which is considered as the base class for C. So C is the class that is derived from class B and B is the class derived from class A. This scenario is known as multi-level inheritance. In order to have a clear picture, you can see the corresponding diagram on the screen. Class A inherited by B, class B inherited by C. But here we have to be very careful that when we are writing the class C, we need to be careful that what members class B is having and in which section. That means what members either of its own or taken from class A are present in the public section, what members are present in the private section, and what members are present in the protected section. As you all aware that private members cannot be inheritance of public and protected members categorically depends upon the visibility mode in which the class C is going to inherit the class B. So we have to be very careful here that the middle level class, I can say class B here, what all content this class is having and under which section. So class C is allowed to take what and under which scenario, or we can say the data members of each respective base class are accessed by their respective derived class according to the specified visibility modes. So it is not only visibility modes, but we have to be very careful with what members are present into what section, because here it is also about the members which B has inherited from class A as well. Now coming to the general syntax, we can say class A, as it is the uppermost base class as we have seen in the figure. So class A and definition. Class B is going to inherit the class A or inherit the members of the class A. So we can say class B colon visibility mode private, public, protected, class A, and then there is a definition. Now after this definition, B is having some we can say members, some of its own and some taken from class A. And now class C, which is the declaration says as class C colon visibility mode class underscore B, or visibility mode of class B, public, private or protected, followed by its class definition. So class A inherited by class B inherited by class C. That will be the general syntax. Now let us talk about in terms of an specific example. So here we have class A, which is class electronic device, or first class, or the formal or the foremost the base class, we can say. It is having one public constructor of the base class 1 which is electronic device, saying I am an electronic device. It is just a simple statement. So, here is the definition of our class A or the first base class. Now, this electronic device class will be inherited by the next class, which is class computer. So, we will say class computer colon public electronic device, meaning you all aware that class computer is inheriting electronic device in the public mode, and it is having one of its own constructor, which is obviously named as computer, and having a cout statement, I am a computer. That is it. Now, A we have defined, class B inheriting class A, we have defined that as well. Now, here in this situation, our class computer is having two members. One is its own constructor, which is computer, and another one is the constructor of class electronic device. Both are available in the public section as per the as per the rules of inheritance, as per the public visibility mode. Now, coming to the last level of the class, which is here named as Linux based. Now, this Linux based class is inheriting the class computer, which in turn has already inherited the class electronic device, and it is giving one constructor of its own, which is named as, obviously as it is the constructor, it is named as Linux based, and the statement is I run on Linux. Now, what is happening here? Whenever I am saying that this Linux based is inheriting the class computer in the public mode, so what is happening? Now, this Linux based class in its public section is having three functions or three member functions, we can say. One is its own constructor Linux based, another two members which are coming from the class computers public section. One is the constructor of class computer, another one is the constructor of electronic device class, which computer has inherited from its base class, which is electronic device. So, finally, your Linux based is having three member functions, one constructor of its own, another constructor of its derived class, its immediately derived class, and another the constructor of the derived class of its derived classes. And whenever we are creating the object of the derived class, which is the object of the final derived class, we can say, which is Linux based, automatically constructor of base class 1 and base class 2 will be called along with the derived class constructor. And what output here we are expecting is actually this. So, I am an electronic device, then printed I am a computer and I run on Linux. So, see, if you can see the hierarchy here, first the I am an electronic device. This statement is given by the constructor of the first class, which was, we can say, the class on the topmost level of our multi-level inheritance, which is the electronic device. Now, this electronic device is further inherited by the class computer, and then we have the constructor execution of the class computer saying that I am a computer. Again, further it is printed that I run on Linux. So, basically what is happening? This you can imagine in such a way that whenever object is being created for Linux based class, it is in turn calling its derived class, and whenever the constructor of its derived class, which is computer, is being called, it is calling its immediately kind of base class, we can say, which is the electronic device. So, first of all, the execution of the we can say execution of the topmost base class electronic device class constructor is completed, giving the statement I am an electronic device. Then at the second level, the execution of the constructor of the base class which is in the middle is completed, which says I am a computer. Finally, which says I run on Linux. This is the this is the actual object which we have created, which in turn called the computer, and the computer class constructor in turn called the electronic device. So Linux, then computer, then electronic device. So electronic device first, then computer, and then Linux. So this will be the, we can say, kind of leveling or the sequence of the constructor being called, and this was the we can say output which we were expecting. So basically what is happening, multi-level classes, why we are saying this as multi-level inheritance, one class is inherited by a single class at each level. That's why this is known as multi-level, and there are 2-3 levels, and the object of the derived class Linux based can access the members of the class electronic device and the member of the class computer directly, because the electronic class is inherited by the subclass computer, which is further inherited by the subclass Linux base. So this was the situation. Now coming to our fourth type. So till this point we have seen single inheritance in which there is a single base class and single derived class are there. Then we have seen multiple inheritance in which there are multiple base classes giving their features to a single base class. Then we have seen the third one, the third type of the inheritance which we have just seen is multi-level inheritance, in which let us say a class A is there being inherited by class B further is inherited by class C. Now coming to the fourth type, which is hierarchical inheritance. So hierarchical inheritance is the inheritance in which a single base class inherits multiple derived class. This is known as hierarchical inheritance. That means base class is giving its features to many kind of derived classes. This inheritance, as the name indicates, hierarchical inheritance, is a tree like structure, since every class acts as a base class for one or more than one child classes. So I am just repeating it once again. This inheritance, it is having a tree like structure. I am just going to show it in a while. So a tree like structure, because every class is acting as a base class for either one of the child class, or it could be for more than one child classes. And yes, very importantly, we have to see the visibility modes as well. So in hierarchical inheritance or in any type of inheritance involving many base classes, we have seen the visibility mode for each of the derived class has to be specified separately during the syntax or while writing the definition of the derived class, and the derived class access the data members accordingly. That means whatever visibility mode has been specified, according to that visibility mode, the data members of the base class will be accessed by the derived class. So in order to understand the concept of hierarchical inheritance, let us see a figure. Let us say we have a class A which is being serving as the base class for two classes, class B and class C, while your class B is having two derived classes, class D and class E, and your class C is also having two derived classes, class F and class G. So at the root of this tree like structure which I was talking about, there is one base class, class A. Then there are two derived classes of these base classes, class B and class C. Class B is having its two derived classes, D and E, while C is having F and G as its derived classes. Now let's try to see the syntax. So we have class, which is the topmost class on the root, class A, which is not inheriting any of the class, so class A is there. Then we have class B, which is inheriting class A, so definitely a visibility mode has to be there. So class B colon visibility mode class A, and then followed by its own class definition. This is, till this point, this is just an example of single inheritance, one base class and one derived class. Now proceeding further, we have class C, which is inheriting class A with a specific visibility mode. Now we have class D and class E. So class D and class E are having visibility modes for deriving class B, and let's say E is deriving class C. So we have the structure A being derived by B, and B, which is again being derived by D. Similarly, we have A, which is being derived by C, and C, which is again being derived by E. So in the tree structure, we have shown the two classes, two derived classes at the last level, but in the example we have taken only one. So class A, then B and C derived from it, and D is derived by B, and E is derived by class C. This is the structure which we are going to take here. Here you can kind of specify. Here you can see that class E is inheriting class C in a specific visibility mode. Class D is inheriting class B in a specific visibility mode. So at the last level, just for the sake of simplicity, we have not taken two derived classes for each of the base classes B and C. Instead, we have taken one derived class D for class B and one derived class E corresponding to the base class C. Coming to the specific example of this, let us say we have class electronic device, and then a constructor of this electronic device which says see out, I am an electronic device, and which closes the definition. Now coming to this, was we can say are the topmost base class, we can say as if you want to compare, this is the class A of the figure. Then we have derived class inheriting that class. So we have class computer, which is public, which is inheriting the electronic device into public mode. We are not having any definition of this class for the sake of simplicity. Here you can give the definition according to the requirement of the application. So this is, as per analogy, we can say this is our class B. Then another derived class inheriting the base class electronic device, which is Linux based, and it is also inheriting the electronic device base class in the public mode. So here also we have not specified any definition. So till this point, as compared to the figure, we have seen A, which is the electronic device, then we have class computer, which is taken as B, and class Linux based, which you can take as class C. Then coming to the next level, in which we have to use the class computer as the base class for some class, and we also have to use the class Linux based for some class. So what are we going to do? We will be completing this definition by the we can say another level. Let us say class computer 1, public computer, then class Linux based 1, public Linux based. So this particular structure, again it will, if we are having only one derived class for each class computer and Linux based, it is going to give us just one single inheritance scenario. So this has been kind of left as do it yourself exercise. I can say it is just going to give you two class definitions simply, one which is inheriting the class computer, another one which is inheriting the class Linux based. Now in the main class, we are constructing the object of the class computer and we are constructing the object of class Linux based named as object 1 and object 2. So here you can see integer main. Then in order to create the object of the derived class, we have seen we have written computer obj1, which is constructor of the base class, it is being called. Then constructor of the base class, again base class will be called of, now which base class I am talking about? I am talking about the base class Linux base obj2, and as shown in the we can say our hierarchical tree structure, what output I am expecting is I am an electronic device and again I am an electronics device. Now why it is being happening is, here you can see in the code that computer obj1 is the creation of the object obj1 of the class computer whose base class is electronic device. So whenever, and here notice in the definition we have not written any definition within the brackets, or we have not written any definition for the class computer. Also we have not written any definition of its own for the class Linux base. So basically what I can say is, in the public section of computer and in the public section of Linux based, there is going to be one constructor which is the constructor of its base class, and here we are taking the mode as public, so that is very clear here. So whenever we are saying the constructor the object obj1 of the class computer is being called, that means constructor of its base class will be called, which is electronic device. Similarly, when I am saying the object 2 obj2 is being created, as Linux based, the class Linux underscore based is not having any definition of its own, that means the despite of not having any definition of its own, it is having one member function which is nothing but the constructor of its base class, which is electronic device. So in both the statement, whenever we where we are creating obj1 and where we are creating obj2, in both these sentences we are actually calling, because of the absence of the body of the class, we are actually calling the constructor of the base class for computer, which is electronic device, and constructor of the base class for the Linux base, which is again electronic device. So here you can see in the output, which this will say I am an electronic device and again I am an electronic device, and this was actually we can say is the expected output. So here in hierarchical inheritance, till this point what we have seen, we have one base class which is, let us say, class A, and this class A is being inherited by two different classes. One is class B and another one is class C. So this particular scenario is actually, we can say, the opposite of our multiple inheritance. In multiple inheritance we were having multiple base classes and a single derived class which is deriving all the base classes. Here in this, the scenario is opposite. We are having multiple derived classes derived from a single base class, and then at the we can say third level we can have more derived classes derived from the middle level base classes. So here in this lecture what we have completed is the two types of inheritance. One is the hierarchical inheritance, which we have just seen, and previously we have also seen multi-level inheritance. So, multi-level inheritance gives you we can say different levels of inheritance. So, class A inherited by class B, and class B again in turn inherited by class C. And for these two, apart from these two, we have already covered single inheritance and multiple inheritance, and rest types of inheritance which we are left with will definitely be covered in the upcoming lectures. Here is a list of references used. Hope you have enjoyed the lecture. Thank you for patient hearing.